Alright, what's up? About to teach y'all some math with a hoodie on. Today, we're going to talk about solving quadratic equations using square roots. And here's the step-by-step process of how to solve them. First, we're going to isolate the x squared by itself. Or if the x is in the parentheses, then we isolate the parentheses by itself. So if it's just the x squared like this, we try to move everything away from it, like all the numbers to the other side of the equal sign. But if the x is inside the parentheses, then we move everything away from the parentheses, and I'll show you that. Using algebra, you don't just magically erase. Take the square root of both sides and then solve. You got to remember to do this whenever you're dealing with a square root. Answers, plus and minus, are positive and negative answers when taking the square roots. And I'll show you an example, but we're going to follow this pattern and this strategy over and over and over again. Alright, so I want you to notice on each one of these three examples that none of them have an x to the first power. Why? Because you can only use square roots or solving using square roots if you don't have an x to the first power. If you remember, all of our quadratic equations can be written like this. A is the coefficient on x squared, B is the coefficient on x, and C is just the constant. You cannot solve using square roots if you have b to the first power, bx to the first power. So something like this you couldn't do. 3x squared plus 5x minus 4. See, I don't have anything that's x to the first power. You may say this one is, but it's really not, because that 2 is going to make that x to the first power. So anyway, just throwing that out there. And if you actually paid attention to what was written in the notes here, I guess it's not on there. But this is another way to solve quadratic equations, and I think I was about to lie anyway, so never mind. Alright, so let's jump into it. How do we solve a problem like this? The rules say isolate the x squared, and so that means remove everything. So I got a 2 multiplied and a 1 being added. You always remove your addition and subtraction first. So I have 2x squared equals 16. Then in order for me to solve for x squared, I have to divide by 2. And remember in class we spoke about this. We cannot stop or say we're done if we got a 2. We have to be able to get rid of that 2. And the way you remove that 2 is to take the square root. Of course, you got to do it to both sides. And so you would say something like this, plus or minus the square root of 8, because there is no number times itself. However, using our trusty handy-dandy calculator, our scientific calculator, we can figure out that this right here can simplify. And so, yes, I want your answers written in simplest radical form. And how do you do that? I'm going to do second square root of 8. And when I do that, it gives me 2 radical 2. So what is your real final answer? X equals plus or minus 2 square root of 2. 2, not 8. So that's a 2. King, right? Alright, now, just to show you something real quick. Your mode on your calculator, if you hit that, if you notice it says classic and math print. If you go down here to classic and you hit enter, and then you go back and do the square root of 8, notice how it looks different now, and you get a decimal. The classic gives you the decimal, and whenever you want it to simplify, you go to math print, and then you do it. You see how it doesn't give me the parenthesis there, and I just hit enter? Some numbers are too big, and it'll just give you a decimal anyway. But you can always hit the button on top of enter, and that'll change it to a decimal or back and forth if you wanted to. Alright, just kind of help you. Alright, let's look at number 2. So notice my x is inside the parentheses on number 2. Okay, I'm hot now. The x is inside the parentheses on number 2. So I'm not worried about the square root yet. I need to get rid of this 1/3. So I am going to multiply everything or both sides by 3. Doing that kills that over here. So all I have is x plus 5 quantity squared equals 21. Right? 7 times 3. Then this is where you take the square root. And so I get x plus 5 equals plus or minus the square root of 21. Now, if I put that in my calculator, notice what I get, the square root of 21. And I hit enter, and it gives me the square root of 21 back. That means that it doesn't simplify. So I'm going to keep it like this. I'm not going to change it to a decimal unless I ask you to. Subtract 5 from both sides. Now, you can't subtract 21 and 5, so this is how you write your answer. Negative 5 plus or minus the square root of 21. You actually have two answers here. If you really wanted to know, that's negative 5 plus the square root of 21, and that's negative 5 minus the square root of 21. Both of those are two different decimals, but this right here is all I need. So you solve for your x or your x squared. If it's written in parentheses, you solve for that, meaning move everything away from it algebraically, and then take the square root of both sides. All right, let's look at number 3. First thing you want to do is subtract. Why? Because you got to get rid of that 2 and that 18. You subtract from both sides, you get 2x squared equals negative 18. What do you do next to solve? You divide by 2, and x squared equals negative 9. So far, so good. How do we get rid of this 2? Just like we've done before, we take the square root of both sides. That leaves us with x by itself equals plus or minus the square root of negative 9. But we have a problem here. You should never have a negative number underneath the radical. And so the issue is, how do you deal with that? How do you deal with a negative number underneath the radical? We don't stop here. The way you deal with that, I'll come back to this problem in a second. The way you deal with that is whenever you have a negative number underneath the radical, it's really an imaginary number. And the way we deal with that is to simply say 5i. Well, that's not the way that they mostly want to see it, so it's mostly written like I square root of 5. You see how the 5 became positive underneath the radical and this I just came out of nowhere? You don't want your I underneath the radical, so that's why it's almost always in front of the radical. So the way you deal with this is you do not leave a number negative underneath the radical. You make it positive, but you have to also add an I. So I'm going to do that. I'm going to make it positive, but I'm going to add an I. You see that? It's now positive, but there's an I. Now tell me, what is the square root of 9? We can actually simplify this. If you put it in your calculator, you'll get 3. That is actually your answer. You won't have many of those, but you need to know how to deal with them if they come. What about if I had, this is an extra example, but that first problem I had, what if it was x squared equals negative 8? And I took the square root of both sides, and that was x equals, well, I'll say that that's, I'll take that negative and make it an I. Now the 8 is positive. And when I simplify that, I would get x equals 2i radical 2, because that's what comes out. So any number that comes out of the radical, you put that in front of the I, and whatever stays underneath the radical should turn into positive. It should never turn positive without an I. Okay? And you should never have a negative and an I. So the only time you deal with something like what I'm doing down here on number 3 is if you have a negative number underneath the I. Now this is not underneath the radical. My drawing sucks. But that's why most of the time you see the I in front. So whenever you come across a negative number underneath the radical, make sure you make it positive, but also add an I. And we'll talk about imaginary numbers later in detail, but for now this is how you deal with those. And I'm pretty sure y'all remember them or should know of them from last year. Alright, if you got any questions, ask your mama.